Hello everyone, welcome to RN Tutorials. So in this video we are going to discuss how to find out the moment of inertia of a circular plane. Okay, so here how to find out the moment of inertia circular plane. For that first we try to assume a circular plane of section ABCD. So this is the figure which is I am assuming as ABCD. Okay, so for this circular plane we need to find out what is the moment of inertia formula. Okay, so next we need to assume the radius as r. So the radius of the circle as r we are assuming. Okay, from the center, and similarly we need to consider the two reference axes x and y like this. Okay, so these are the two references axes we need to assume for finding the moment of inertia, and the smaller is the radius of the circle. So to find out the moment of inertia of all this section, first we need to take a small elemental strip which is having a particular diameter with a particular thickness. So I want to assume with respect to the center O, which is the elemental strip. Okay, so which is having the radius small x. Okay, mean radius as a small x, and the thickness of the section, that sorry, thickness of this elemental strip of the circle as dx. Okay, so with reference to this elemental strip, first I want to write what is the moment of inertia of this elemental strip with respect to the z-axis. So z-axis means we know that which is axis perpendicular to these two reference axes x and y. So first we need to write what is the moment of inertia over the z-axis first for this elemental strip. Then we have to go for the moment of inertia of the whole section over the z-axis. Then we can find out easily what is the moment of inertia of this circle about x-axis and about y-axis. So for that we have to write the moment of inertia of the elemental strip about the z-axis, which can be written as, already we know, integration r square dA. Okay, for this reference of elemental strip about the z-axis, so we can write it as, initially only for the elemental strip means it is r square dA. So with reference to this elemental strip, the moment of inertia of all this section can be written as integration r square dA, integration perpendicular distance whole square into area of this elemental strip. So this formula gives you what is the moment of inertia of this whole section with respect to the z-axis. Okay, so now we can modify the equation as, so r square means here the what is the perpendicular distance. So the perpendicular distance means the x is the radius with respect to the z-axis to the elemental strip. So as it is, we can write it as x square. And the area how can we write it as here for this elemental strip of thickness dx? How can we write the area? Means here the area can be written as 2 pi x into dx. So how it can be 2 pi x into dx means this 2 pi x is the circumference of this elemental strip, and the dx is the thickness of the elemental strip. So the product of these two will be giving the area of this elemental strip. How it will be means, when you cut this elemental strip and unwound it until it becomes straight, what will be the shape? The shape will be like this rectangle. After cutting at any particular point and unwounding this circle until it becomes straight, then the shape will be rectangle. Okay, so what is the length? The length will be equal to the circumference of this elemental strip. So automatically the length can be represented by circumference of this elemental strip according to its radius x, that is 2 pi x. And what is the thickness here? Dx. Okay, so the area of rectangle, what is the formula? Length into thickness, or length into width, or length into breadth. Okay, so the length is 2 pi x and the breadth is dx. So automatically as it is, we can write it as area of the elemental strip as 2 pi x into dx. Okay, so now modify this equation, we'll be getting integration 2 pi x cube into dx. Okay, this is the iz, we can write it as. And next again we can write the equation as, by integrating this x cube with respect to dx, what will be the formula? X power n plus 1 by n plus 1, so x power 4 by 4. Okay, so this is the izz. So for getting the whole section, so once again here izz is the integration of the whole section. So when we get the integration of the whole section, when you apply the limits, here we have given the integration, but we need to represent the limits also. So what are the limits means? 0 to total radius of the circle. So here we have not applied the limits for this elemental area. If you apply the limits to this elemental area, it will cover whole section of the circle. So the next step is, we need to apply the limits for whole section of the circle. We should apply the limit 0 to r. Okay, So when you apply 0 to r to this equation, so what will be, so in place of x, r we need to substitute. Okay, minus 0 means automatically it will become 0. So 2 pi, sorry, so 2 pi means here 2 gets cancels and the denominator will be 2 only. Okay, so that can be written as r power 4 by 2 after applying the limits. Okay, so and r again can be written as, r is the radius of the circle, which can be written as half of the diameter, d by 2. So when you substitute this r is equal to d by 2 in this equation, what will be, pi by 2 into d by 2 whole power 4. In place of r we need to write d by 2. So it is pi d power 4 by 2 power 4 means what it will be, 16. So 16 into 2 it will be 32. So finally we will be getting pi d power 4 by 32. So which is the moment of inertia with respect to the z axis for whole section, for the whole circle with respect to the z axis. Okay, so with reference to this moment of inertia about the z axis, we have to find out what is the moment of inertia about the x axis, what is the moment of inertia about the y axis. So what is the next step should be, so from the figure first we have to analyze. From the figure we can understand that moment of inertia about x axis can be equal to moment of inertia about y axis. Why? Because these two axes are dividing the plane into two equal parts. So automatically whatever the amount of the moment of inertia will be getting about x axis will be equal to the moment of inertia about the y axis. Okay, and again from the theorem of perpendicular lines, from the theorem of perpendiculars we can write the equation as izz, moment of inertia about z axis should be equal to sum of moment of inertia about x axis and y axis. Okay, so again from this analysis ixx can be iyy, so izz is equal to can be written as ixx plus ixs, so which will be equal to 2 ixx or 2 iyy also will be getting when you substitute in place of ixx is equal to iyy. Okay, so now write it as ixx is equal to izz by 2. So izz already we got it as pi d power 4 by 32. So now write down pi d power 4 by 32 by 2, which will be giving 32 into 2. It will become 32 into 2. So then pi d power 4 by 64, which is the moment of inertia about the x axis. That can be equal to again iyy also. So that can be equal to iyy. Okay, so whatever the amount of the moment of inertia will be getting about x axis should be equal to the moment of inertia about y axis. So that is the derivation, and this is the equation for finding the moment of inertia of the circular section about any particular axis. About x and y the formula is pi d power 4 by 64, and about z axis is pi d power 4 by 32. Okay, this is the simple derivation, and we need to remember the formula for the moment of inertia of the circular section about any particular axis xx, yy and zz. Okay, remember the formula which is useful for solving the problems. So I hope you understand, and if you still don't understand, please feel free to give a comment to my video so that I'll try to clarify your doubts. And once again, thanks for watching my video. Thank you all.